Today we're looking at notes K-1, an intro to logs and exponential functions in pre-cal. So we know that you've dealt with this in Algebra 2, so this is just kind of a refresher course. So in part 1, we will be converting back and forth between log and exponential, and we will use the method of swirl. So I know that I've used heart in the past. I know that you might have seen the Nike Just Do It. Whatever you use, it doesn't matter. Just pick a method to use that works for you. So in number 1, if you're given a log, then you are asked to convert to an exponential. So the base of the log will become the base of the exponential. So the base here is 4, so first you'll write 4. And since I'm converting to an exponent, it'd be 4 to the third power equals 64. And is that a true statement? Always check yourself. Yes, 4 to the third is 64. Okay, so let's look at number 2. So here again, the base of the log is 7. So that'll become the base of your exponential. Okay, so 7 to the negative 2 equals 1 over 49. And again, that is a true statement. 7 to the negative 2 is 1 over 49. So I'm going to box it up. We're done. All right, last one here for converting between log and exponential. The base of the log will become the base of our exponential. So 2 to the 2/3 power equals cube root of 4. So again, if you want to make sure that you are doing this correctly, let's go ahead and perform this operation. So 2 to the 2/3. Okay, so remember top dog goes in the house. That's kind of the thing I use. The numerator goes in the house. The denominator is your index. So cube root of 2 squared, well, what is 2 squared? It's 4. So that is a true statement. 2 to the 2/3 is the cube root of 4. So we'll go ahead and box that. All right, so now let's go from exponential to log. So again, the base of our exponential will become the base of our log. So first write the word log. Log base 5 of 125 equals 3. That's where I end up. So log base 5 of 125 equals 3. Here, log base 81 of 3 equals 1/4. And then last but not least here, log base g of 4 equals m. Okay, so in a nutshell, that is converting. Next, we're going to look at some graphs. So hopefully you recall looking at various exponential and logarithmic graphs in Algebra 2. Okay, these bases were just chosen at random. It's a small number, easy to fit on a graph. If you chose like a base of 10 or even 8, those would be pretty large numbers to deal with. So we chose a small base here for that reason. So f of x equals 3 to the x is graphed in purple. So start thinking about x values to plug in. If you plug in 0, 3 to the 0 is 1. So 0, 1. If you plug in 1, 3 to the first is 3. So that's this point here. And then it would keep on growing exponentially, right? You go backwards, you plug in -1, 3 to the -1 would be 1/3, so on and so forth. So it goes this way, but recall that for your exponential functions, as we keep on plugging in less and less and less x values that are negative, this fraction will just get smaller and smaller. It will never, the answer will never be 0, your output would never be 0, and it would never be negative. That's why you have this asymptote here at y equals 0. This graph will never ever touch or pass y equals 0. That's our purple asymptote that you can hopefully see on your end. Okay, so that's our exponential graph, the purple. The red is our logarithmic graph, so log base 3 of x. So remember, for inverses, these are inverses. Log base 3 of x and log base 3 of x and 3 to the x are inverses of each other. So when you have inverses, you switch the x and y's. So this point 0, 1 would become 1, 0, and then so on and so forth. So when the bases are the same, and you have an exponential and a log, those two graphs are inverses of each other. Likewise, similarly, I guess I should say, with the log graph, we do have an asymptote, but it is on the y-axis. Okay, so at x equals 0, this graph will never touch, never cross this asymptote here in red. So remember that when you graph two inverses on the same graph and you draw in the line y equals x, if you were to fold over that line there at y equals x, these graphs would lie on top of each other. Okay, that's because both compositions equal x. Okay, if you find f of g of x and g of f of x, etc., they will both equal x. And that reminds me that one of these should be g, so let's fix that. Okay, so these are inverses of each other. Remember looking at the graphs from last year. So now let's talk about some facts, different log facts. So log base 10 of x can also be written as just log of x. Remember that this is called common log, and when there is no base written, base of 10 is implied. So these two things mean the same thing. Okay, log base e of x, remember that that is our natural log, ln of x. Okay, so and that is called natural log. Okay, and remember that e represents a value of approximately 2.72. E is kind of like pi. Okay, it's a letter that holds an approximate value, okay, and in this case 2.72. So here for these last three, we're going to talk about these values, and I want you to think about the graph, and I want you to think about converting these to exponents. So two things I want you to think of. ln of 1. Remember that for ln natural log, our base is e. So if we wanted to convert this to an exponential, okay, we would be saying e to some power equals 1. That's how you would find the answer here. E to what power equals 1? Well, e to the 0 power equals 1. And if that doesn't make sense to you, then think about the graph. This is your x, and this is your y, right? That's our x, that's our y, input, output. If you put in the x value of 1, you get out y. I'm just talked about a second ago that all of your log graphs will have the coordinate 1, 0. So think about the coordinate on the graph, 1, 0. Input, output. Okay, think about this here. Log base 4 of -6. Again, think about the exponent and then we'll talk about the graph. 4 to what power equals -6? There is no value that you can plug in here. 4 to no such power equals -6. Not a thing, undefined. Can't do it. And then graphically think about why. Our input is -6. For a log graph, can we have an input of a negative value? No, because for our log graph, we have the asymptote here at x equals 0. So hopefully you remember that you can never take the log of a negative number. You can't take the log of a negative number. And you can see that from the asymptote. We can't go over here to the left. Okay, and similarly, e to what power equals 0, if you were to convert this, there is no value you can plug in. This also is undefined. It's not possible. Okay, the asymptote is at x equals 0. So therefore, you cannot have an x value of 0 because the asymptote there. So you can't have a negative input and you can't have 0 for an input for our logs. Okay, doesn't matter what the base is. So let's kind of summarize some things that we found. So log base 5 of 5. Okay, again, if you were to convert this and we're wanting to know what this is, you could plug in x here to talk about what is this. If you convert this, that's like saying 5 to what power, 5 to the x power equals 5? Well, 1. Same here. 6 to what power equals 6? 1. 7 to what power equals 7? So anytime the base and this match, your answer is always going to be 1. So log base x of x is 1. Okay, here, let's talk about this. So if you were to convert this to an exponent, let's talk about this. So e is the implied base. So this is like saying e to the blank power equals e to the 1. E to the what power equals e to the 1? Well, here, if the bases are the same, then you just say the exponents equal each other. If the bases equal each other, the exponents equal each other. So here, our answer would be 1. That's because natural log and e are inverses of each other, so they basically cancel each other out. So here, anytime you have the natural log of e, they cancel out, our answer is 2. Here, same, our answer is 3. Here, same, our answer is x. Okay, keep that up. Here, it's just going to be 2x. Here, it's just going to be 11x. Okay, here it's going to be x to the 5th. And here it's going to be this whole thing, x squared minus 1. Okay, ln of e, those are inverses, they cross out. So here is a similar situation. Okay, if you wanted to convert this to a log, you would say natural log, okay, because log base e of what equals the natural log of 6. If you converted this, if you plugged in an x here because you don't know what this value is, and you converted this exponent to a log, it would say log base e, which is natural log, of what equals ln of 6. Again, e, ln, those are inverses. They cross out. They cancel each other out. They undo each other. So here you can tell x would equal 6. Our unknown is 6. So therefore, e to the ln of 6 just equals 6. Similar here, e to the ln of 7 just equals 7. E to the ln of x equals x. And then e to the ln of x to the 4th minus 9 would just be x to the 4th minus 9. Okay, so keeping that in mind, let's do one more thing. Let's do some simplification. So -1 plus ln of e to the 2x. So again, remember the ln of e, that crosses out. So you would have -1 plus 2x. So just clean it up, put it in standard form. 2x minus 1 would be your answer for simplifying that. Okay, again here, if you have e raised to the ln, those undo each other. So you have 5 minus x squared plus 1. Okay, but be careful because the x squared plus 1 is in parentheses and that needs to distribute through. So it'd be 5 minus x squared minus 1. So here, putting this in standard form, you would have negative x squared plus 4. Okay, and then last but not least, here, ln of e, those undo each other, and so then you would have x to the 3rd minus 7 plus 8. Cleaning this up, you'd have x to the 3rd plus 1. That's it for today.